Object-oriented programming, or OOP, is a programming approach that structures software design around objects rather than functions and logic. An object is a self-contained unit that combines data and methods to manipulate that data. By using objects, OOP helps to organize complex programs, making them more modular, reusable, and easier to understand. This approach models real-world entities and relationships, providing a clear and intuitive way to structure software. Object-oriented programming is based on 4 key principles. Encapsulation bundles data and methods into a single unit, protecting data from outside interference. Inheritance allows one class to inherit properties and methods from another, promoting code reuse. Polymorphism enables a single method to operate differently based on the object it acts upon. Abstraction hides complex details and shows only essential features, simplifying interactions. Polymorphism in object-oriented programming has 2 main types. Compile-time polymorphism. Method overloading, multiple methods with the same name but different parameters. Operator overloading, operators behave differently based on their operands. Runtime polymorphism. Method overriding, a subclass provides a specific implementation of a method already defined in its superclass. Compile-time polymorphism, also known as static polymorphism, is achieved through method overloading within the same class. This allows multiple methods with the same name to exist, as long as they have different parameters. For example, in the same class, voidAddInt A, int b, adds 2 integers. VoidAddInt A, int b, int c, adds 3 integers. The correct method is chosen at compile time based on the number of arguments passed. This enables flexible and readable code. Runtime polymorphism, also known as dynamic polymorphism, is achieved through method overriding. This allows a subclass to provide a specific implementation of a method that is already defined in its superclass. For example, in class A, we add voidAddInt A, int b, which performs addition. In class B, a subclass of A, we override voidAddInt A, int b, to provide a different implementation. When an object of class B calls the add method, the overridden version in class B is executed. The method to be called is determined at runtime based on the object's type, enabling flexible and dynamic behavior. Abstraction hides complex details and shows only essential features. For example, an abstract person class defines common attributes like first name, last name, skills, and jobs. Specific persons like Ram, Priya, and Sam use these common attributes, simplifying how we interact with person objects while hiding the underlying complexity. Single inheritance allows a class to inherit properties and methods from another class. For example, in single inheritance, Class A is the base class with common attributes and methods. Class B extends Class A, inheriting its attributes and methods. This means Class B can use or override methods and access attributes defined in Class A, promoting code reuse and establishing a hierarchy. One before it. Class A is the base class. Class B extends Class A, inheriting its properties and methods. Class C extends Class B, inheriting from both Class A and Class B. In this structure, Class C inherits attributes and methods from both Class A and Class B, creating a multi-tiered hierarchy. In hierarchical inheritance, multiple classes inherit from a single base class. Class A is the base class with common attributes and methods. Class B and Class C both extend Class A. In this structure, both Class B and Class C inherit properties and methods from Class A, allowing them to share common functionality while also adding their own unique features. Encapsulation involves bundling the class's variables and methods together while controlling access to the internal state. Class defines the blueprint for creating objects, encapsulating data and behavior. Variables, private variables within the class that are hidden from outside access. Methods, public methods that provide controlled access to the private variables.